Lesson 84, Degree of an Equation. The degree of an equation is the degree of the biggest polynomial in the equation. So to do this, we have to review a few things. Remember that if we have, for example, x5, y2, m, to find the degree of that term, that's just one term, what we have to do is add all the exponents. So 5 plus 2 plus 1 is 8. So it's an 8-degree term. Now, to find the degree of the equation, let's look at this example. In this case, the degree of each one of these terms is, for the first one, we have to add 2 plus 1, which is 3. The next one, we have to add 4 plus 3, which is 7. And then the other one, we have to add 5 plus 1, which is 6. Now remember that the 2 that doesn't have any letters, the degree is 0. So what we do in this case to find the degree of the equation, we choose the term that has the biggest degree. So in this case is 7. So the equation, let's finish here, put an equals 0. The degree of this polynomial or of this equation is going to be 7. I know you're not going to be using this a lot, but it's good to have this information when you're working with equations. Now, more common example that you might be using more is whenever you're just working with just maybe one variable. So in this case, we have x to the 6th power plus x to the 5th power minus 3x to the 8th power plus 3. In this case, this equation is an 8th degree equation. Why? Because the one that has the biggest exponent is x to the 8th power. So that is the leading exponent, and that would be the exponent of the whole equation. Okay? Very, very simple. Again, just look for the degree of each of the terms and then choose the one that has the biggest one. The second part of the lesson is very simple as well. This lesson doesn't have any calculation. It's mainly just knowing these things. And it's about the types of solutions that we have on systems of equations and how we classify them. So let's think about these. If we graph a line here in this graph, this only has one solution. Remember that the solution is the point where they touch. So that system of equation that is represented in that example has only one solution. Now, if the lines are parallel, notice that they're never going to touch. So this system has 0 solutions. It never touches, so it has 0 solutions. But we could have a case where we have a line, and then we also have another line just going on top of it. And notice that what's happening is that one has infinite solutions. Why? Because they're touching in infinite points. So they have infinite solutions, or they share all of their points. So here on the right, I have these two types of categories. The first one is consistent or inconsistent. Consistent is when it has at least one solution. So we can say that the first one is consistent because it has one solution and it has to have at least one solution to be consistent. The next one is inconsistent because it has no solutions, and to be consistent, it has to have at least one. Now, the last one, it is also consistent. It is consistent because it has at least one solution. It actually has infinite solutions. Now, the next one is dependent or independent. To be dependent, they have to share all of the solutions. So this is the only one that is dependent. And notice it almost means that they depend on each other to exist. So they are dependent. Now the other two are independent. And again, independent means that they don't share all of the solutions. So in the first case, we only share one solution. And in the other one, we don't even share any solutions. Now before we finish, I want to talk about a few characteristics of each of these cases. The first one, notice that it has only one solution. The m and the b's are different, okay? So if we had let's put here an example. y equals 3x minus 1 and y equals 2x plus 5. Okay, those two are going to have one solution, and notice how we have different m's and different b's. In the inconsistent independent, the m's are the same, because remember that for two lines to be parallel, they have to have the same direction. They never touch. And if they have the same direction, it means that they have the same slope. But the b's are different. Okay, the b's are different. Notice, this b is here and the other b is here. And that's kind of like saying the location. Where does the line go through? Now, if we think about an example in this case, it will look something like this. Y equals 5x minus 1 and 5x plus 7. So notice the m's are the same. The m's are 5. And then the b's are different. In the last example, the m's are going to be the same and the b's are going to be also the same. Now you might think, but that's the same line. Well, yes and no, because the way that they're going to give it to us, it doesn't look like it is the same line. So look at this example. In this case, they're not the same line. 3x plus 2y equals 5 is not the same as 6x plus 4y equals 10. But if you notice, if I leave y alone, we are going to end up with the same equation. And the other way to see that they are the same or that they are dependent and consistent is because you see that they are like a multiple of each other. So if I multiply the top one by 2, all of the terms, then we get the one on the bottom. 2 times 3 is 6, 2 times 2 is 4, and 5 times 2 is 10. So there is a relationship in that way. And that's it. This is a really important table for you to copy and have just to remember the different types of systems that we have and their solutions. Okay? So just make sure you study these and get familiar so that you can identify them whenever you are asked. Okay? Very easy lesson, just a lot of theory. Make sure you memorize it, and I'll see you in the next video.